Hey, welcome to our lectures on organic chemistry. We're going to have two of these, and they're going to be separated into essentially this being able to convert line drawings to Lewis structures, structural formulas, condensed formulas, and molecular formulas, and functional groups. We will have a little bit of this organic chemistry definition at the first end and the significance of functional groups first. So basically this part and then this part. Okay, so the first goal, know the definition of organic chemistry. Second goal is understand the significance of functional groups. And then the third would be to be able to convert line drawings to Lewis structures, structural formulas, condensed formulas, and molecular formulas. And finally, be able to recognize functional groups in compounds. So let's take a look at organic chemistry. A very simple definition of OChem, organic chemistry, is that it's the study of carbon-containing compounds. So this has nothing to do with organic being like the farmer's idea of organic, which means that there are no unnatural pesticides used. You can use pesticides, but they just have to be natural pesticides. Like you can use ladybugs, that's a pesticide for aphids or aphids, however you pronounce that. And the idea of a functional group is it's a group of atoms that has a characteristic set of chemical properties. So that's the reason we use the word group. We've learned that a group is a column of elements that have similar chemical properties. Well, a functional group is not an element that has elements that have a similar set of chemical properties. It's a group of atoms bonded together in a particular way that has a characteristic set of chemical properties. Now, the types of functional groups we want to be able to recognize, and this is going to come a little later, but it's a quick introduction, are just these, looks like 14 of them. This is a very limited list. There are quite a few more functional groups, but these are the main ones. There are alkanes, alkenes, alkynes, aromatics, and cycloalkanes. Collectively, these guys are called hydrocarbons because they have hydrogen and carbon in them. There are alcohols, ethers, amines, and what are called haloalkanes or alkyl halides. If these things sound like they're alkanes with halogens, it's because they are. And then there are things called aldehydes, ketones, carboxylic acids, esters, and amides. So those are some of the different functional groups, and alkanes will all react the same way. Alkenes will all react the same way. Alcohols will all react the same way chemically. So our chapter spends a lot of time looking at reactions of these different things. And, in my opinion, it's a little overboard. You spend a whole year studying organic chemistry if you're a chemistry major, a whole year. And our chapter tries to jam in a lot of those common chemical reactions into one chapter. So I will give you just a smidge of the organic chemical reactions that you'd learn in organic chemistry. Not even 10%, 1% of the reactions that you would learn. And there'll be simple reactions, or the simpler reactions. All right. So what I really wanted to spend time on in this first part of the organic chemistry lecture is converting line drawings to Lewis structures. So here's some things that you may want to write down and come back to and refer to when we start looking at line drawings. In line drawings, every line is a bond. So if you see something like this, that is a bond, and that is a bond. So there are two bonds shown here. If we did something like this, that's not drawn too well. I'm going to cross that out. I'm going to draw again. That shows three bonds, a single bond and a double bond. If the line ends in a symbol, the bond is to an atom of that element. I don't see any symbols here, so we don't have any bonds to oxygen. We don't have any bonds to nitrogen. We don't have any bonds to fluorine. If the line does not end in a symbol, the atom is carbon. So what that means here is if we take a look at this guy here, this line is a bond. And since we don't have symbols, that bond is between two carbon atoms. What is this bond between? Well, it's between two carbon atoms. So if the line does not end in a symbol, the atom is a carbon, period. No ifs, ands, or buts. That's the rule. Every carbon must have 4 bonds. Those that do not show 4 bonds in a line drawing have enough hydrogens bonded to make 4 bonds. So if we take a look at just this guy right here, can you see that that carbon only has 1 bond? So how do we make that have 4 bonds? Well, we add 4 hydrogens to it. Now, I'm not going to fill in the hydrogens on the rest of the carbons. That's something that you may want to try to do for yourself. So here we have some examples, and I've actually done it for you. So here are some line drawings. So here we have 2 lines. So those are 2 bonds. And since we don't have any elements being shown here, they are bonds between carbon atoms. So here you can see I've substituted carbons at the ends of each line. And then what I do is for each carbon, I add single bonded hydrogens to each carbon until I get 4 bonds on a carbon. So on this first carbon, I add 3 hydrogens. On the second, I add 2 hydrogens. On the third, I add 3 hydrogens. Let's look at this line drawing. Can you see that there are 4 lines? And 2 of these lines that are parallel, that's a double bond, and it ends in oxygen. So that means this is a double bond to oxygen. From what atom? Well, since there's no element being shown here, that atom is a carbon. So this is a carbon double bonded to an oxygen, but this same carbon is also singly bonded to another carbon and singly bonded to yet another carbon. So now we have to add hydrogens in, and we also want to add in lone pairs. So we want to add in lone pairs to get an octet. You'll notice we didn't have to do that over here because each carbon has an octet. But here, this oxygen, we have to add 2 lone pairs to get an octet. And this carbon, we have to add 3 hydrogens to it to get 4 bonds. This carbon already has 4 bonds. A double bond and 2 singles are 4 bonds, right? And so here is the Lewis structure for this line drawing. Here's yet another line drawing. It's a nitrogen with 2 lines sticking off of it and a hydrogen next to it. So one of the things that people make a mistake in when drawing the line drawing of something like this is they forget to understand that the hydrogen is singly bonded to every other atom that it's bonded to. So some people forget to put this bond in here. So I've done that very quickly. And there should also be a lone pair on the nitrogen, so that has an octet. And here, since this line ends at nitrogen, it's going to be a bond between carbon and nitrogen as I've shown here. Same for this line here. We see that it ends in nitrogen, but the other end, we don't show what's there, so it has to be a carbon. Okay, so how many hydrogens are bonded to each of these carbons? Well, enough to get 4 bonds. So I have 3 hydrogens here and 3 hydrogens here. And this is the Lewis structure of this compound. Okay. Now, what about a structural formula? How is that different than a Lewis structure? Well, a structural formula, you don't show lone pairs. So here in this compound here, there are no lone pairs. So this is the Lewis structure, and on the right, this is the structural formula. It's kind of a weird thing that we call it a structural formula when it's really not a formula, it's more of a structure. Here, this is one of the compounds that we drew before, and we don't show the lone pairs, but here's the structural formula. So that means the lone pairs are implied. Not that they're not there, but they are implied. And likewise here, this is the Lewis structure of one of the compounds we have, and this is the structural formula. Okay, so what's the big difference between a Lewis structure and a structural formula? The structural formula is the same as the Lewis structure, but lone pairs are implied. Okay, now how do we take a structural formula and convert it to a condensed formula? I call the condensed formula the typewriter formula because they're pretty easy to write on a typewriter. Well, the idea here is that you write down the first branch atom and then the terminal atoms that are bonded to it. So branch atom is an atom that's bonded to two or more other atoms. Can you see that this carbon is bonded to 1, 2, 3, 4 atoms? So that's a branch. So we start off with this carbon and we write a C. Then what we do is we list all of the terminals that are bonded to that carbon. And there's 3 hydrogens. And instead of writing CHHH, you write CH3. The next branching atom is this carbon. So you write a C. How many terminals does it have on it? 2 hydrogens, so H2. And then CH3. So this is the condensed formula for this Lewis structure. Let's take a look at some more examples. So here, this is not a molecule we've seen before, but it's similar to one we've seen before. So this would be a structural formula because we don't see the lone pairs there implied. So here, the first branching atom, and I like to work from the left to the right, is a carbon. So I start with carbon, and then I have 3 terminal atoms. So the terminal atoms, again, are atoms that are bonded to this at dead end. And there's 3 of them. And then we have a carbon. What are the terminals on this one? An oxygen. So here, when you have a double bond like this, it's nicer to write it above the atom that it's bonded to. You want to show double bonds, okay, or triple bonds in your condensed formula. And then finally, we have CH3. So let's take a look at this. This is another structural formula. And here's my CH3, then a nitrogen with a hydrogen bonded to it. That's a terminal. And then here, since this guy's above, I put it like that. However, we could have written it like this, CH3NH, CH3. And likewise, we could have written it this way, CH3 parentheses 2 NH. So this one's a little more challenging. How do we convert these to molecular formulas? Well, that's easy. Just count the types of each atom and basically put them in alphabetical order. So 1, 2, 3, 3 carbons, 3, 5, 8, 8 hydrogens. 1, 2, 3, 3 carbons, 3, 6, 6 hydrogens, 1 oxygen. 1, 2, 2 carbons, 6 hydrogens, plus another one for 7, and 1 nitrogen. So that's the molecular formula. Okay. So the next thing we're going to do is we're going to be looking at organic chemistry and recognizing functional groups. All right. Thank you for listening, and get ready to play the next video. Let's see, how do I pause this?